So you think 0.1 plus 0.2 equals 0.3. But if you ask a computer, it'll tell you something different. Open a Python terminal and type in 0.1 plus 0.2, and you won't get 0.03. You'll get 0.03, a bunch of zeros, and a 4. This isn't a Python bug, it's a computer problem. Try it in JavaScript, Java, or C++, and you'll get the same thing. The problem is that we use a base 10 number system, but computers use binary, or base 2. To understand this, think about the fraction 1/3. In our decimal system, it's 0.333 repeating forever. You can't write it perfectly, so you have to round it, which creates a tiny error. For a computer, the numbers 0.1 and 0.2 are like our 1/3. In binary, they become infinitely long repeating fractions. Because computers have finite memory, they're forced to cut them off and store the approximation. This system is called floating point arithmetic. So when you ask Python to add 0.1 and 0.2, you're actually adding two slightly inaccurate approximations. These tiny errors add up and give you that strange result. So how do you deal with this? Python gives us the right tools for the job. First, for displaying numbers, you can round the result. Rounding 0.1 plus 0.2 will give you a clean 0.3. This is great for making outputs look good, but it really only hides the underlying problem. Second, for anything that needs perfect accuracy, like financial calculations, use the decimal module. This avoids the binary problem entirely. You have to import it, and this is critical, create the numbers from strings. If you write decimal 0.1 plus decimal 0.2, you'll get exactly decimal 0.3. No errors, no approximations. Third, never compare floating numbers directly with double equals. A check like if 0.1 equals 0.2 equals 0.3 will fail. Instead, check to see if they're close enough using math.isclose. Using isClose to check if 0.1 plus 0.2 equals 0.3 will return true. This is the only safe way to compare floats. So 0.1 plus 0.2 not equaling 0.3, it's not a bug, it's a necessary trade-off. Computers live in a binary world where some of our simplest numbers become infinitely complex. Knowing how to handle this is key. Remember the playbook. Use round for clean display, math.isclose for safe comparisons, and the decimal module when accuracy is non-negotiable, especially with money. Understanding your tool's limits is a huge step forward in becoming a better programmer. If you enjoyed this deep dive, subscribe for more secrets behind the code that we use every day. Thanks for watching, and remember to always begin secure.